Number 2 on the 2024 AP Calc AB exam is actually quite simple. You do need a calculator to solve all of the parts, most if not all of the parts. I remember I just solved it just now, but I'm pretty sure I used a calculator for most of them. But the setup is actually quite easy. Okay, so this first one says a particle moves along the x-axis so that its velocity at time t greater than or equal to 0 is given by this function. There's one time t equals t sub r in the interval 0 less than t less than 2 when the particle is at rest, not moving. Find t sub r. For t between 0 and t sub r, is the particle moving to the right or to the left? Give a reason for your answer. So when the particle is at rest, the velocity is 0. So v of t sub r equals 0. Okay, so t sub r is 1.426. You got to graph this guy and then find when it crosses the x-axis. So that's when t is 1.426. Okay, so now the second part is the particle moving to the right or to the left between 0 and t sub r. Well, the velocity is positive, so it's going to move forward. In this case, it's to the right. Part B, find the acceleration of the particle at time t equals 1.5. Show the setup. Is the speed of the particle increasing or decreasing at time t equals 1.5? Explain. So acceleration is the derivative of velocity. So you could find this by hand. It's actually not bad at all. But since you have a calculator, put this as y1, and then y2 is like n derive of y1. And the a sub 1.5, if you plug it into the calculator, it is -1. There's no units given here, so you don't need to put units. Okay. So now to answer the second part, the speed increasing or decreasing. Well, we got to find the velocity. Okay, so if you find v of 1.5, that's minus 0.0768, blah, blah, blah. Now you got to check, is the acceleration and velocity the same sign? It is. So that means the speed is increasing. The particle is moving backwards, but it's moving backwards faster and faster and faster. Okay. But the speed of the particle is increasing at t equals 1.5 because both velocity and acceleration are negative. Okay. If both of them are positive, it's speeding up in the forward direction. If both of them are negative, it's speeding up in the backwards direction. If they're opposite sign, then that means it's slowing down. Position of the particle is at time t is x of t, and the position at time t equals 1 is x of 1 is -3. Find the position of the particle at time t equals 4. Show this up for your calculation. This is a classic definite integral setup. Integral from 1 to 4 of the velocity is equal to x of 4 minus x of 1, because integral of velocity is the position, and position is x of t. So by fundamental theorem calculus, x of 4 minus x of 1. This left-hand side, plug into your calculator, integral of this guy from 1 to 4. Okay, x of 4 is what we want. X of -1, they give us that as -3. So it becomes 3 plus this 0.197, blah, blah, blah. So it's this guy. Find the total distance traveled by the particle over the interval 1 less than equal to t less than equal to 4. Show the step. Okay, so the step is just this. Integral from 1 to 4, absolute value of the velocity. Plug this into your calculator, you get 0.95813, and you're done. See, this one's pretty easy. So the steps are all easy. You just got to punch things into your calculator carefully.